we got to be able to figure out what the substance is or what the particle is that's going to be produced by a certain amount of decay. So in this case we have lead. Notice our lead that we start off with has a mass of 204 and it has an atomic number of 82. That 82 coincides with the periodic table atomic number for lead. And notice that it's giving off a helium nucleus. What type of decay is this? If it's helium that's being given off, that's alpha decay. Okay, easiest one to spot because it gives off helium. Okay, it changes, another way of looking at it is it changes the mass as well as the atomic number. So how do we figure out what substance the lead becomes as it gives off its helium nucleus? Well, we take the mass over here of 204. We know that this mass of 4 here had to come out of that 204. So we do 204 minus 4, which is going to give us 200. And then on the bottom, we have atomic number of 82, so 82 protons. These 2 protons were part of that, so we're going to do 82 minus 2, which means that this gets 80 protons. And if we look that up on the periodic table, it turns out that that is mercury. So our lead is going to turn into mercury, okay, mercury 200, and will give off a helium nucleus. Okay, so how did I do that again? Here's the steps. First, you want to figure out the mass number. So you take the left number and the right number, subtract them, figure out what's left for this particular substance. Then you want to figure out the atomic number. Take the atomic number, subtract the protons that came out, in this case a 2, and that'll give you this, which would have been 80. Okay, and then last but not least, you got to look up this 80, the number on the bottom, the atomic number on the periodic table, and that will tell you the substance, which in this case is mercury. Okay, so let's do this again. Got another practice problem here. So next practice problem is looking at copper. Okay, so this copper has a mass of 66. It has an atomic number of 29. Okay, and we know that it's going to turn into zinc. So notice that the mass did not change at all. It goes from 66 to 66, but the atomic number did. So it's not alpha decay because alpha decay changes both. Okay, and it's not gamma decay because gamma decay changes or doesn't change either one. They both stay the same. Okay, the only thing that's changing is the atomic number. So that tells us it is beta decay, but which one? Is it normal beta decay or is it positron decay? Well, let's figure this out first. So we take the number on top and subtract it from the number on top over here. So in other words, the mass and the mass, 66 minus 66 will give us 0. That's the mass of our particle that's being given off, our radiation that's being given off. And then we take the atomic number here and we subtract the atomic number over here. Okay, it's important that you take what's on the left and subtract what's on the right. So 29 minus 30 is going to give us -1. Okay, so what substance has a mass of 0 or particle has a mass of 0 and a charge of -1? An electron. Okay, and that since electrons have a negative charge, this is beta negative decay, also known as just simply beta decay. This is not positron decay. If this was positron decay, this would be a positive electron. Okay, easy as that. So we have 3 practice problems here at the bottom. What I'd like you to do right now is pause the video, try and figure these out on your own. If you get stuck, turn the video back on, watch me until I catch up to where you are, and then once you have confidence to keep going again, pause it, see if you can finish up. Okay? Good luck, and give it a try. Alright, hopefully you gave it a try. I hope. But if not, here we go. So here we have boron. This is radioactive boron. It's going through decay. We need to figure out what substance it becomes. So we take the mass on the left, the mass on the right, taking this mass and subtracting this mass over here. 8 minus 0 is just going to give us 8. 5, the atomic number over here, minus the atomic number over here. 5 minus 1 is going to give us 4. Look that up on the periodic table. That's going to be beryllium. Okay, so pretty easy. Subtract 8 minus 0, 5 minus 1, and we know that this boron becomes beryllium. Okay, now continuing on, we have carbon 11. Okay, we take our mass here. This mass is being split between these 2 substances. So the beryllium is going to take a mass, 7 units of the mass. So that means that we have 4 units left over. 11 minus 7 gives us 4. Then as far as the atomic number, the number of protons, carbon had 6. 4 of them go with beryllium. So 6 minus 4 is going to give us 2 protons left. What has a mass of 4 and a atomic number of 2? A helium nucleus. Okay, so just going backwards just for a second, let's identify the types of decay. This first one gave off a positive electron, also known as positron. Okay, so this is positron decay. And this one here gave off a helium nucleus, so that means this is alpha decay. Alright, last but not least, let's look at this thorium decaying. It has a mass of 231. Our palladium that we create in the end, that's more stable, also has a mass of 231. So 231 minus 231 means that our particle has a mass of 0. And then we take the atomic number on the bottom and subtract the new atomic number. So 90 minus 91 is negative 1. What has a mass of 0 and a charge of negative 1? An electron. So this is normal beta decay, what we call beta or beta negative decay. Okay, so that's it. Make sure you complete your whisk, and we'll see you tomorrow.